Okay, today we are going to learn how to find the area of a triangle using matrices. Well, why in the world would you want to do that? We've known how to find the area of a triangle since we were little tiny, Mrs. Kidd. We do 1/2 base times height. Well, that's all well and good, but if you think about what this guy looks like, 3, 8 would be up here somewhere, -2, 5 would be over here somewhere, and 0, -1 would be down here. And finding the area of that guy is not going to be so fun. So we can use matrices instead. So we're going to use this formula here. The area equals plus or minus 1/2 times, what do these straight up and down bars mean? No, they do not mean absolute value when you're talking about matrices. They mean determinant. So remember that notation. Those straight up and down bars mean determinant. So we're going to do plus or minus 1/2 times the determinant of this 3 by 3 matrix. These are your x and y coordinates of your 3 ordered pairs, and the third column is always going to be 1s all the way down. Well, why do we need those 1s? Why can't we just leave that off? Well, because if you remember, you can only find a determinant if it's a square matrix. So without those 3 1s, it wouldn't be a square matrix. So we have to do that. Okay, doesn't matter which ordered pair you start with, but once you start, you got to go around the shape, okay? So here we go. So first thing we're going to do is we're just going to set this up. Plus or minus 1/2 times the determinant. I'm just going to go in this order, A, B, C. All right, so this would be my x coordinate, my y coordinate, and a 1. Okay, so this is x, this is y. My x coordinate, my y coordinate, and a 1. My x coordinate, my y coordinate, and a 1. All right, before we multiply the 1/2, we want to find the determinant. So remember, on a 3 by 3 matrix, to find the determinant is a little bit more work. You're going to copy the first 2 columns over. Then you're going to go on the diagonals, right? So our first diagonal is 3 times 5 times 1. So that's 15. Second diagonal is 8, 1, 0. Woohoo, magic 0. Third diagonal is 1, -2, -1. So 1 times -2 is -2. -2 times -1 is +2. Minus, it's always minus when you're finding determinant. And then we do the other way diagonals, right? Woohoo, magic 0. Second one is -1 times 1 times 3. So that's -3. And third one, I've just lost my place, is right here. 1, -2, 8. So that would be -16. So 15 plus 0 plus 2 is 17. -3 and -16 is -19, but we still have that minus from in the middle. So 17 minus -19 becomes plus a positive. 6, 1, 36. All right, but we haven't done this part yet. Because just like when you were in elementary school and you did 1/2 base times height, we still need that 1/2 in there. So we have to do 1/2 times 36, which is 18. Now, you might be thinking, why do we have that plus minus out there? Here's the thing. Based on the order that you go around the triangle, in one direction, the determinant will be positive. So then a positive 1/2 times a positive 36 would give you a positive 18. In the other direction, if we'd have done this in the other direction, we would have ended up with a -36. Well, we know that area can't be negative, so we would want to multiply that by a -1/2 so that we still end up with a positive 18. So you are not going to have 2 answers. You're only going to have 1. So if this number is negative, then you want to multiply it by a negative so that you end up with a positive. So the area of this triangle right here is 18. So let's go back through just one more time real quick what we did there. We took the coordinates of the vertices and we put those x's in the first column, y's in the second column. We made our third column all ones so that we had a square matrix so that we can take the determinant. So then we find the determinant of that square matrix and then multiply it either by positive 1/2 or negative 1/2 so that we end up with a positive number. And that's all there is to it.